And we're live, people. Welcome. My name is Mr. Stoker. I'll be your tour guide. Okay, let's go through this. Even spaces on the motion map up here because it's going the same speed. And you're going at 1 meter a second. It's going to take 5 seconds to go there. For number 2 here, you're really just using the idea of speed. Think back to Forrest Gump here. Speed is distance over time. And you're either finding the time or the distance or the speed, whatever's missing. So 16 on this one, 3.3, no, that's not right, 33 seconds on that one, 30 centimeters there. Now the next part was maybe the trickiest part on the worksheet. The velocity should be increasing by 2, so it's 2, 4, 6, 8. Remember the distance then, you can either use the formula or you can use the think it through method, whichever one. So it's going to go 1 meter, 4 meters, 9 meters, 16 meters. The pattern that Galileo noticed was that you take the time and you square it, and that's the distance. You know, at 1 second, square it, you get 1. 2 seconds, square it, you get 4. 3 seconds, square it, you get 9. 4, square it, you get 16. That's why the formula that we use for our shortcut formula has the time squared in it. Now it just so happens for this particular ramp problem that the acceleration is 2, and when you take half of 2 you get 1. So it works out to be exactly the same as the time squared. Most of the time that doesn't happen. But we made up an example where it kind of was obvious that way. Okay, so second page. For the rock falling here, the speedometer is at 0, then 10, 20, 30, 40, 50, and 60. The distance then would be, using your formula or your think it through method, is going to be 5 and then 20 and then 45. Let's see, what's the next one? 80. Is it 125? And 180. For those. Filling in the blanks here, speedometer is increasing by 10 meters a second. We call that acceleration. Distance increases as the square of the time. Once again, that's why the formula has a squared in it if you're using the formula method. Going to be 70 meters a second, that's 245 meters, and the acceleration is still 10 the whole way through. Okay, we go to the third side. After 4 seconds, you'll have $40. Ball is dropped after 4 seconds, going 40 meters a second. You see how those are like the same kind of scenario? After 3 seconds, you have $50. After 3 seconds, you're going 50 meters a second. 5, you run out of money after 5 seconds. You run out of speed for the arrow after 5 seconds of going up. So what's the arrow's speed at 5 seconds? Well, it's 0. It's the very peak here. It stopped moving for a split second. Then at 6 seconds, it's fallen down 1, so it speeds up to 10. At 7 seconds, it's fallen down 2 seconds, so it speeds up to 20. Okay, now they're doing distance. When you shoot it upward and it runs out of speed, it's starting at 50, ending at 0, it's 125 meters. You can use the shortcut formula because you are ending at 0. Remember, starting at 0 or ending at 0, it works for that. How high will it be after 7 seconds? Well, now it's fallen back down for 2 seconds. So you know it went up 25. Falling for 2 seconds will drop 20 meters. So subtract the 20 from 125, you're at 105. Drop a penny in 3 seconds, it's going 3 meters a second. Its average speed is 15, so the distance is 45. So they're getting you to go through the think it through method by doing the average. But now that if she throws it down at 10 meters a second, you find the average speed now, times it by 3 seconds, it ends up being 75 meters. Okay, let's go to the last page. Okay, so the idea here, and maybe it wasn't super clear on the worksheet I made, but find the velocity at each point. You're covering 2 blocks, so that's 2 meters a second, then 4, then 6, then 8. You're increasing by 2 meters a second every second. 10 meters a second, then 7, then 4, then 1. So you're decreasing by 3. I guess technically I should say that's negative, shouldn't I? And on this one, you're increasing by 1 meter per second every second. This last one seemed to be a little tricky for people. You had to think about when we did the runner acceleration lab, we were finding the slope of the velocity time graph. So these are velocity time graphs, so the slope of this line is your acceleration. The steeper the line, the faster you're speeding up. The less steep, the slower you're speeding up. So rise over run, we get 2 meters per second squared. Here we get 1/2 meter per second squared. And down here, this usually is tricky for people because they count from 0 a lot of times. No, count from where the line actually is. You're dropping 4 and going over 4, so it's -1 meter per second squared. Any questions on that?